I made the tiniest error while explaining this before, so I just had to do it like this. Okay, pumpkins from a large crop are found to have a mean weight of 4.1 kg. So let's draw that. So we've got these pumpkins, we're going to call them X, the random variable, 4.1, standard deviation 0.45. Calculate the probability that a pumpkin weighs between 3.3, so pumpkin, like that doesn't mean pumpkin, it means probability. The lower bound of 3.3, between 3.3 and an upper bound of 3.7. So the pumpkins, the random variable X, is between 3.3 and 3.7. Okay, so this is what we're looking for. So I don't really need to have my book anymore. So clear if I just do it like this. Now, we're looking between here, 3.3, and here, 3.7. We want to find all of the pumpkins in this. What is the probability that a pumpkin is in this area? Between 3.3 and 3.7. Now, to explain this, we're not going to be able to do like what we normally do with 0.5 minus or anything. We're going to have to use another piece of logic, and it's the final piece of logic. That means that you'll be able to solve all of these questions using your tables. Now, I'm going to draw two Z's so I can illustrate what is happening here. Now, the first one, I'm going to go and find this value. So let's do it. Z equals X, 3.3 minus 4.1, the mean, over standard deviation, which is 0.45. Got a calculator for that. Okay, can I use my thing? I think I can. 3.3 minus 4.1, and then we go divided by 0.45. So that means this Z value here is negative 1.778. Remember, round the third dp. Okay, so that is this area here. Okay, well that Z value is going to correspond to that area there. Then the next one we're going to do is the 3.7. Right, we're going to do here 3.7. No. Dang it, this is the mistake that I had to move to a book for in the first place. The numpty. Okay, it is, let's find the Z value. Z is, and we get the X value, which is 3.7, and put it here, not down there, yeah, numpty. Come on, Mr. Forbes. Okay, 3.7 minus 4.1, and then divide it by 0.45. The Z value is negative 0.889, and that will help us find this area. Now let's do that. Let's use our Z tables and we'll find them. So the first one is 1.778. remember, it's symmetrical, so we are going to use that idea, but we've probably built up understanding enough that we can just skip ahead. So 1.778, 1.77, so it's where are we going to do this? I'm going to do it up here. 1.77 is 0.4616, and then we're adding on a difference of 8, which is 0.0007. I'm just going to show you where I found that, and I'm also checking because I may have made a mistake. So see how we've got 1.77 is 0.4616, and then that difference of 8 at the end means we're going to add on a 7. Yep, looks good to me. So that means this area is equal to 0.4623. Yeah, right, that's this total area. Now let's do this one here. So we're going to get 0.889. 0.889, I'm going to highlight that. 0.88 is 0.3106. add on our difference of that 9 at the end, so that's 0.0025, and then that will give us this area. So it's going to be 0.3131. Okay, now here comes the explanation. This is the logic. If I am looking for the area between here and here, if I get this area here, that's 0.4623, and then I minus off this area here, and I'm going to do this one like that, right? If I minus off this area here, it's going to give me the leftover. So it's, if we're getting this area and we minus this area, it's going to equal this area. You guys see that logic? If we have the total area from here to here and we minus off from here to here, we're only going to be left with here to here. So that means this area can be found by getting the total area from 0 down to 4.1 down to 3.3. And that was 0.4623, and then we just minus off this area that's in there, or this area here, which is 0.3131, and that will find us the leftover chunk that we're looking for. So that's the final piece of logic. These are like the hardest questions, for the hardest of the straightforward questions. So yeah, that means we're going to be left over with 0.1492. So therefore the probability that a pumpkin is between 3.3 and 3.7 is 0.1492. There you go. Okay, now you've made it this far. It's so much easier to use the graphics calculator. We played you the whole time. We're making you use old flippin' technology. Where in life are we using flippin' tables? Are we living in the annals of history? Like, come on, it's like testing you guys on doing mental arithmetic. Probability tables. We've got computers, calculators. Why are we testing this? Look at this. Go to your calculator. Click distribution. Click normal. Click this for cumulative or between. You put in your blimmin' mean. Oh wait, your lower is, look at this, 3.3. Voila. Your upper is 3.7. Voila. Your standard deviation is 0.45. Voila. Your mean is 4.1. Voila. And look at this, the probability, 0.1493. That's even more accurate. Like the calculator is giving us a more accurate probability. Using a table is so out of date. And then the fact that we make you have to go and buy a graphics calculator, is it a better way to do, like, it's stupidity. Look at this. In real life, in real flippin' life, we've got computers that can do these things for us. We have programmers that can set up, like, how to do these things. Where are we going? Okay, so here we got normal distribution. Look, where is it? Yes, Mr. Forbes, normal distribution. Great. So here you type in your mean. What was our mean? 4.1. What was our standard deviation? 0.45. What are we looking between? We were looking between 3.3 and 3.7. So you don't need to have a graphics calculator, but because you're sitting an NCA exam, you do. Look at this. Probability 0.1493. Fact of the matter is, you are going to use your table in an NCA exam if you don't have a calculator. If you don't have the graphics calculator, you're going to have to do it this methodology that's been done on the past few pages. If you don't have the tools, you just learn, you just become smarter. You're going to become better. And having this understanding of the tables is actually going to be pretty useful for later questions anyway. So maybe it's not all bad, but you should be able to look at this and say, this is archaic, this is out of date. This is not even like good technology. This is like a basic little bit of programming on some graphing technology, or using your calculator to do this. This would not be too hard to program, because it's, yeah. Anyway, rant over. There you go. We finished.